Math 8, Unit 4, Graphing and Slope, Lesson 12, Part 2, Systems of Linear Equations, Solution Types. So you need to be able to recognize when a system has no solution, one solution, or infinitely many. Now, thinking about this graphically, there are three options. It is possible that both of our lines will they'll be parallel, therefore they will never cross. Since the point where they cross is the solution and they don't cross, there would be no solution. Another possibility is that there is one solution, so the lines do cross at just one point, and that is the solution. The third option is both lines are exactly the same line, and every single point on that line is on both lines because it's the same line. So every point on the line is a solution to the system. Those are our three options. Either they don't cross, they cross once, or they cross everywhere. It's not possible for them to cross twice. Just think, 2 points determine a line. If I try drawing another point that goes through both of those, or another line that goes through both of those points, it will be exactly the same line. Therefore, it'll cross at every point. So that's the option, either 0 solutions, 1 solution, or infinitely many solutions. Well, what leads to these happening? Well, let's think for a moment here. In order for there to be no solution, look at the slopes. Well, the slope is the same. Well, instead of saying slope same, let's say same slope. So if we have the same slope and a different y-intercept, then we will have parallel lines, there will be no solution. You also could have the same slope in this situation, but it would also have the same y-intercept. If you have the same slope and the same y-intercept, it's the same line, therefore there are infinitely many solutions where every point on the line is a solution. The other option is having a different slope. In fact, in order for there to be one solution, they do have to have different slopes. That's going to be a quick thing you can quickly check. Now, it doesn't matter the y-intercept. If the y-intercept's the same, then they cross at the y-intercept. If the y-intercept's different, they cross somewhere else. It doesn't matter about the y-intercept on how many solutions there are. But this is how you can tell. If they're the same slope and different y-intercepts, then they're parallel. They'll never cross, no solution. If they are the same slope with the same y-intercept, they are parallel, but they're also the exact same line, so there are infinitely many solutions. If they have different slopes, they'll go in different directions, and they are going to have to cross somewhere. So let's look at some quick examples here. Determine the number of solutions to each system. Explain how you know you do not need to solve. Y equals 3x plus 2 and y equals 2x plus 3. Now, first thing I notice here is the slopes are 2 and 3. If they are different slopes, they go in different directions and they will cross somewhere. So there is one solution. And the reason I know is the slopes are different. Okay, next example. Y equals 1.5x plus 5.1 and y equals 1.5x plus 6.2. Now I'm going to take a look at slopes. The slope on both of them is 1.5. This means the lines are going in the same direction. They are parallel. Now we just need to check to see if they are the same line or if they are different lines. The y-intercepts are not the same. So these are parallel. There is no solution. And the way I know that is parallel lines do not cross. See, they're parallel and not the same line. Because if they were the same line, they would cross everywhere. They would just be the same line. So this is no solution because I know the lines are parallel because their slopes are the same. All right, let's look at this one. Y equals 2x plus 3 and 2x minus y is negative 3. Before we can do this one, we need to solve for y. So let's get rid of 2x on both sides here. So negative y is negative 2x minus 3. Change the signs. We get y equals 2x plus 3. So checking slopes. Slope is 2, slope is 2. The slopes are the same. So they are parallel. Let's see if they are exactly the same line. Y-intercepts plus 3, y-intercepts plus 3. They are exactly the same line. So this has infinitely many solutions. And the way I know is they are the same line. Because they're the same line, any point on the line is a solution because it will work for both lines because they're the same line. All right, determine the number of solutions, explain how you know. You do not need to solve. So on this one, let's just take a quick look. The slopes are the same. The intercepts are the same. It's the same line. Infinitely many solutions. And we know it's infinitely many because they are the same line. Okay, next example. Y equals 4.5x plus 12 and y equals 4x plus 12. Checking the slopes first. The slopes are different. If the slopes are different, they will cross because they're going in different directions. So this has one solution. And I know it's one solution because the slopes are different. Now on this one you might notice that the y-intercepts are the same, they're both 12. That actually just means that they cross at the y-intercept. So the solution is 0, 12. Next, y equals 5x plus 4 and 5x minus y is 3. Before we can answer this, we need to solve for y. So we have it in slope-intercept form. Divide by -1. So that's just changing the signs. So that's a horrible looking y. Let's try that again. Y equals -3 plus 5x. So checking the slopes. 5 and 5. The slopes are the same. Let's check the y-intercepts. 4 and -3. The y-intercepts are different. Because the y-intercepts are different and the slopes are the same, these are parallel, so there is no solution because lines are parallel. Okay, in the practice here, on number 1, you're just going to solve using the transitive property. Remember, if two things equal the same thing, then they equal each other. Number 2, determine without graphing the number of solutions each system has. Justify how you know the number of solutions. You do not need to find the solutions. Just tell me how many there are. Number 3 is a review of solving absolute value equation. Number 4, you're going to find the area of this figure. I recommend cutting it into 2 triangles. You can find the area of this triangle and the area of that triangle and just add them together. Number 5, you're going to do a dilation of the triangle ART. Scale factor is 3. Number 6, you're going to find the ratio of the areas, image compared to pre-image. Is this what you expect? Now back in Unit 2, we learned that the dilation factor affects the area by a square of the dilation factor. So if the dilation factor here is 3, we should expect that it is 9 times the area. 3 times 3, 9 times the area. Number 7, you're going to consider this linear system. It's in 3 variables. You're just going to verify that this is the solution. You will just plug it into everything. X is 2, y is -2, and z is 3. So in the first equation, that would be plugged in, and if that's true, that's great. You try the second and the third equation, and you're just showing that that is the solution. Now, number 8 is a 2 trains problem. This is just your classic problem. You got the 2 trains that are going towards each other. You're going to want to create a slope-intercept equation for the blue train and an equation for the red train. Look for the point where they cross. The point where they cross is when they will pass each other.